Imagine that you're working on a research paper and you realize after you've produced a draft of the paper that you need to go back and change one of the tables because you had an issue with the sample that was included in that table. There's two ways to get out of this pickle. One is to go through, try to manually figure out where the issue was, rebuild the data, then rerun all the analyses, and so on and so forth. The second way to fix it would be just to click a button and have it reproduce everything, including your paper. Obviously, the second one sounds a lot easier, but it does rely on the clean coding principle of automation. In the Gentzkow and Shapiro guide to coding practices, they introduce two rules for automation. One is to automate everything that can be automated, and two is to create a single script that can be run to reproduce all of the operations that were done as part of the research. These aren't just nice features to have in a research project, they're the difference between quality science and academic folklore. And they're also becoming more and more required by top journals in economics and other fields. These top journals won't publish a paper that doesn't come with a fully reproducible code base. So what do we mean by automation? Well, automation just means that the human is not in the loop with producing whatever the output is. With a simple example, let's say you're trying to download some data from the US Census Bureau's website. You could open up a web browser, type in the web address to the artifact that you're trying to get, click download, save it into your folder, and then copy it from the downloads location that you're going to be using for your data analysis. The second option would be the automated version of that option, would be to simply write some code that fetches the data artifact from the Census Bureau directly. And then you don't have to open a web browser, you don't have to do any pointing and clicking. That's what we mean by automation. And then second, what is this script that will be run to reproduce all operations? Well, let's look at that in more detail. This is an R script that illustrates both approaches. So the top approach is the non-automated approach, where maybe we have an R script called model1.r. We run it, it produces some estimate output, and then we manually update that in an Excel spreadsheet, and then anytime we change the model, we have to redo those steps. The automated version of this is to have a single file that will do all of the commands, and then that will allow you to reproduce everything with a minor change, and you won't have to be in the loop. You can do it, you can set it to run right before you go to bed, and then it can be running while you're getting some sleep. So that's the benefit of having an automated workflow, and I can definitely speak from experience. Very recently I had the same type of thing come up where one additional unit came into my sample. I had to rerun all of the results, and I was really glad that I had this single script that could reproduce everything, because even though it took several hours to run, all I had to do was just change one line of code and then rerun it all, and then I got everything in the form that I needed. As far as benefits to automating, there are several. So one is it saves you time during debug. So if you're trying to find an error in your code, it's going to be much easier to find that error if you've automated your workflow, because typically computer software will spit out line numbers where an error occurred. And so if the error is happening in an automated workflow, it's going to be easy to detect, whereas if you had a manual workflow where you're copying and pasting information into and out of spreadsheets, there could be a mistake in the human part of that workflow, and then it would be much more difficult to isolate. Automation, as I've already illustrated, comes with time savings. Again, I was just saying, you change your sample just a little bit, you need to rerun all your estimation routines to get the results that you're looking for. It's much easier to do that if you have a single script that you can just hit run. And then finally, an overlooked or somewhat overlooked aspect of the gains to automation is self-documentation. If I went back to that screenshot that I showed you, I can see the sequence of steps much like a recipe in a cookbook. And so I don't need to worry about saying this file comes first, then this file comes next, because it's immediately apparent to anyone who's looking at that single script that needs to be run. So that's a little bit about automation and why it could be valuable in an academic research setting. In the next video, we'll talk about how to optimally organize folders and use version control for keeping track of changes in code.